Hello students, welcome to classroom. I hope you are all doing well. In today's class, we will be learning the rules for drawing ray diagrams for lenses. So let us learn the rules together. So there are three rules: rule 1, rule 2 and rule 3. Now these rules are similar to the rules you have already learned for mirrors. Okay, so when it comes to the statement is same. It's just that now the application will be done for lenses. Okay, so that is the only difference. So it's actually a very easy session. Okay, so let us start with the first rule. Rule 1. I will write the statement first. What is the statement for rule 1? When incident ray okay, let's just write capital. When incident ray travels parallel to the principal axis after refraction, then after refraction it passes through focus. So this is the rule 1. Okay, now let us draw the lenses here. So first I'll draw the convex and okay, one rule I think, or should I do, and better do one rule each. So all right, then okay, so we'll mark the aperture. Always mark the aperture. In both the lenses you mark the aperture. I want you all to grab your pen and a book and then practice. Okay, with practice you learn better. So after that you draw the principal axis for both the lenses. Then this center is the optical center. Okay, then okay, we can mark the focus now. So this is a convex lens. Okay, left side, right side, let this be f1, and same here, you mark this as f2. Okay, and then same distance, if you give it, you will be getting 2f2. Same distance, if we go back again, we get 2f1. Okay, this is everything that you have to mark on the principal axis. Optical center, f1, 2f1, f2, 2f2. Okay, now statement says that the incident ray travels parallel to the principal axis. So this is the principal axis. So this line is the principal axis. So the incident ray has to travel parallel to the principal axis in rule 1. So let us draw the incident ray traveling parallel to the principal axis. This is the incident ray. This is the IR, the incident ray, which is traveling parallel to the principal axis. The statement says after refraction, so it has touched the aperture, so refraction will take place, it passes through focus. So how will it pass? It will pass through focus. That means it will pass through f2. So it will pass like this. Okay, it's passing through f2. Okay, this is the rule 1 in convex lens. Now let's apply the rule 1 for concave lens. So same thing, let's mark our f1 and f2. So let this be f1, same distance, you get your sorry, this is f2. Okay, not f1. On the right side we get f2, left side is f1, so make the same distance. So this becomes my f1, same distance, if we go back we get 2f2. okay, so everything is marked on the principal axis. Now we're at rule 1, so the incident ray should travel parallel to the principal axis. So the incident ray is here, traveling parallel to the principal axis, and now refraction will take place. After refraction it will pass through focus, but this is concave lens. Okay, so be careful here. The original ray will diverge and go away, but then it will appear as if it is touched the focus. So the divergent ray, the diverged ray will go away like this. So the original ray goes away like this, but on retracing it back, it will appear as if it is passing through focus. All right, so this is rule 1 for both the types of lenses. Now rule 2, okay, rule 2. So let me erase this. Like I said, it's not difficult, okay? It's not difficult. Now, rule 2. When the incident ray enters through focus, then after reflection, then after refraction, it travels or it passes, same na? It passes parallel to principal axis. So let us apply this for in both the lenses, so convex and concave. Aperture, principal axis, optical center. The statement is when the incident ray enters through focus, then after refraction it passes parallel to principal axis. So here is my f1 and this is my 2f1, this is my f2 and this will be my 2f2. According to the rule, the incident ray enters through focus, so the incident ray will enter through focus. So let it enter through focus like this. Okay, so the ray enters through focus. Now it has touched the aperture. Okay, refraction will take place, and after refraction, according to the statement, it will go parallel to the principal axis. So this is how the ray will travel. Okay, now let us apply the same thing for concave. Now concave, so same thing. This is my f2 at the same gap to f2, maintaining the same thing. You have your f1 and 2f1. The ray enters through f1, isn't it? So the ray enters through f1. So how will it go? So let us aim the ray. Okay, let us aim the ray for f2. Okay, let us aim the ray for f2. So if the ray is aiming for f2, so okay, so like this. Okay, the ray is aiming for f2. Okay, let it enter. Okay, the ray is aiming for f2. Now it's aiming for f2, or is it not aiming? It should aim for f2. So let me do this correction, slight correction. I have to make the ray touch the aperture, so that is the problem. Yes, let's do like this. This is more accurate now. So if you trace this line, it's aiming for f2, isn't it? So the ray, okay, this incident ray is aiming for f2. Okay, according to the statement, the incident ray enters through focus. So this ray is targeting the focus. Okay, if you trace this, it will go and touch the focus. Okay, so the ray is on its right track, aiming the focus. Okay, now after refraction, now it has only touched the aperture, so refraction will take place. After refraction, how will the refracted ray pass? It will travel parallel to principal axis. So refraction will take place and it will go parallel to principal axis. So this is how the ray diagram will look like. Okay, for concave lens, you have to practice a lot. Convex lens is very easy. Concave lens, okay, you need to practice more. Okay, so it's easy only, but needs quite some practice. Okay, so this is rule 2 for both concave and convex. Now we go to rule 3. Okay, So let's do rule 3. So in rule 3, the statement is when the incident ray enters through optical center. Okay, so when the incident ray enters through the optical center, then after when the incident ray enters to the optical center, then after refraction also, after refraction there is no deviation, means the ray continues in the same path. You will understand what it means now. So this is the convex lens, aperture, always aperture. This is the principal axis, this is the optical center, this is the concave lens, this is the aperture, this is the principal axis, and this is the optical center. Now the statement says when the incident ray enters through the optical center. So the optical center is here at this point, so the incident ray will enter through this. So let us draw the incident ray aiming for the optical center. So it has already entered the lens and it is at the optical center. Statement says after refraction, so refraction is taking place, there is no deviation. That means this ray will continue the same path. So this is the refracted ray. See, it's an undeviated straight path. This is rule 3. Now let us do the same thing for concave lens also. So for concave lens also, the optical center is here, so the ray is aiming at the optical center. So this is how the ray is going. It should be straight. So straight. Now the rule says that if the incident ray aims the optical center, then there is no deviation. That means this will also continue in the same path. So rule 3 is quite easy in both the cases. In both the mirrors. Rule 3 is easy for both the mirrors, concave as well as convex. It's very easy. So this is the third and the final rule. So in this video we have just discussed the 3 rules, which you have to master. It's not very difficult, it's easy, just that give some extra time to learning concave lens, because there you may struggle a little bit, or also it's very easy when it comes to convex lens. So I'll end the video from here today, and in the next video we'll learn about the different cases. There are 6 cases for convex lenses and there are only 2 cases for concave lens. We'll be learning about that in the next video. So I'll see you there in the next video.